Okay, good evening again, everyone. We are again on our live stream tonight, and our topic is fire protection, which includes, of course, safe means of exit or egress, fire detection and alarm system or FDAS, toxic gas detection and extraction, and stairwell pressurization, and extinguishing agents, and a discussion on automatic fire sprinkler system. So I'm Engineer William J. Juan, a professional electrical engineer, a registered master plumber, an MEPF practitioner, as well as a solar energy advocate. So let's proceed with our invocation. Amang banal, pinupuri ka namin at pinasasalamatan sa mga biyaya at sa tuloy-tuloy mong paggabay sa amin. Maraming salamat po sa pagkakataon na makapaglingkod sa aming mga kapatid at sa aming bayan. Sana po magawain ito ay magbibigay ng dagdag na kalaman, kakayahan at kaunlaran ng bawat isa para sa aming bayan. At sana po ilayo mo po kami sa sakit at saka sakuna. Lahat pong ito ay aming tinataas sa iyo, dakilang Ama, sa pangalan ng iyong anak na si Jesus. Amen. Okay, so let's look at our table of contents. So here we have rearranged this from its original sequence, no? Of course, we will be discussing again the backgrounders or introduction, and then number 2 will be this topic on safe means of egress or fire exits. So what to see when to ensure that our means of egress are safe. Then number 3A is fire detection and alarm system. Number 3B is toxic gas detection and extraction. This is our baby, toxic gas detection, including carbon monoxide detection. And 3C is smoke extractions, and 3D is air pressurization of stairwells, and 4 are fire extinguishing agents, and 5 is a discussion on wet sprinkler system or requirements of sprinkler design. Okay, so let's start immediately our introduction. So again, let me emphasize that fire protection, including FDAS, should be mandatory. No? Yes, in order to save lives, in order to save properties. And again, our data from the Bureau of Fire Protection shows that the Philippines had 17,000 fire incidents in 2015. Causing more than 3 billion worth of damages on properties. And additional data shows from the Bureau of Fire shows that 70% of fire incidents at that year occurred in homes. And in another survey, it shows that 84% of Filipinos consider fire as a second top threat to physical safety. And next of course, this is next of course to earthquake. So earthquake is the number one worry among Filipinos because every now and then earthquake would occur. Okay, and there is a worry that when an earthquake occur, many of the buildings in Metro Manila might collapse. Okay, and of course physical threats include building collapses, which is 69%. Terrorism is also a high at 64%. So that's the reason why maybe the government is also fast track the anti-terrorism bill. No, and floods is not so much of a problem, is 33%. So fire is a worry, 84%, and 40% of the causes of fires is electrical in nature, and so many incidents, fire incidents has happened in the past, which includes here in my list, is not updated actually. In June of 2017, 37 people died is the Resorts World incident. And there was this Kentex fire in 2015 where so many people died, 70 people, with so many uh, affected, no, injured. And 3 is Tuguegarao Bed and Breakfast Hotel fire in 2010, and 16 died. And the Manor Hotel fire in 2001, 75 died. The Damas de Filipinas in 1998 with 53 died. And the Lang Center fire also in 1998, 27 died. And the worst is the Ozone Disco fire in 1996 where 162 died. So you see, every now and then there is this accidents or incidents. They continue to occur even if we continue also to upgrade our protection system, even if the government also continue to find ways on improving, like they do the inspection and so on and so forth. So sometimes these accidents, fire accidents still do happen. And what really worries us, especially yours truly, is the number of people that are affected. And like in the past, so many would die, no? Okay, so another survey also shows that 17% of Filipino homes have fire alarm systems, no? Only 70%, while commercial buildings have 97%. So this is a very big disparity, no? Homes, only 17% of homes have fire alarm system, while commercial buildings have 97%. Okay, so there's this problem. It seems like the law or the implementers of the law only require the commercial buildings to have this. Maybe because in commercial buildings will have more people than in the homes. But the problem is in the homes, you have people there that are sleeping, so they could also be in danger of being of perishing in a fire that may happen in their homes. Another result of the statistics is while commercial buildings have fire exits, smoke detectors, sprinklers, CCTVs, houses do not follow the same standards of protocols. No? So, commercial buildings have very higher level of provision for safety in terms of fire, but houses do not. No, houses do not have smoke detectors and sprinklers, and only a few have CCTVs, and even the fire exits are not really defined strictly as or being followed strictly by those by the implementers for those homes. Okay, so if you analyze this slide, I am just telling you a possible situation, a scenario that may happen. No, say for example, in your home there are no smoke detectors or fire sprinklers, and you work very hard, and you spend a good Friday weekend, and then an accident may happen. So while you're sleeping, an accident happens, then you could be a possible candidate for the statistics on the next day, and an unfortunate result of that fire that may happen. So what is our suggestion to this? Okay, our suggestion is for the 2008 fire code to be upgraded. No, maybe the IRR, the implementing rule, may be upgraded to make mandatory the installation of smoke detectors in every home, because as per our findings, only in the commercial buildings are the FDAS or smoke detectors are being implemented more strictly, showing about 97% of commercial buildings has these smoke detectors, and only 17% of the homes has this. So that's the big danger. If there is a fire that may happen in the homes, then uh, maybe many people might perish. Okay, number two suggestion from yours truly is to make mandatory the installation of detectors of toxic gases, no? Toxic gas detectors. That means I'm pointing at carbon monoxide and hydrogen sulfide. These are the gases, toxic gases that may be present in the homes or inside buildings, no? And these toxic gas detectors should cause an alarm to wake up the people inside the building or to alarm them. And extraction fan, exhaust fan or extraction fans must also be installed to ensure that these toxic gases will not stay in the room during a fire, but they should be sucked out of the enclosure of the air-conditioned space in the building. So let's repeat. Number one suggestion is to make mandatory the provision of FDAS, fire detection and alarm system, in every home, not only in office or commercial buildings. And number two, to make mandatory the installation of toxic gas detectors, alarms, and extraction system. So these are not yet in there. It's not also in the NFPA yet. This number two. Only number one is in the NFPA, except that in the IRR, it is not very strict when it comes to every home. Okay? So, let us analyze our present design of the fire detection and alarm system. To cause an alarm and awaken a human being, the following human senses respond. No, number one is the sense of smell. So if there is a fire and you are inside the burning room, then chances are you will be able to smell the smell of the fire. So that means it could alarm you, or it could alarm the person that is inside a burning room or building. Okay, of course, this is in the assumption that the person has no problem with his sense of smell. Okay, number two is the sense of hearing. So today, the sense of hearing, we have the audio visual alarm included in the fire detection and alarm system. So therefore, the sense of hearing is actuated or is utilized. Okay, and number three is the sense of seeing. Like I said, these two are in the present design, audio visual. How about sense of feeling? The sense of feeling is not yet there, but we have suggested already, and that is by the use of smart watches, mga relos, no, that has the capacity to vibrate. The smart watch must have a SIM card inside, so that in case of a fire, the programmable logic control or the fire alarm control panel, which is a computer, will send a signal to the SIM card of your smartwatch, and the smartwatch will vibrate, and therefore it will affect this sense of feeling for an individual, for him to be awakened. So therefore, as of today, inside the burning room, you have the sense of smell, then the sense of hearing is part of the FDAS today, and the sense of seeing is also part of the FDAS because of the alarm light, the rotating beacon, and the LED lamp. And the sense of feeling can already be included, but of course only in the addressable type. In the conventional, it is not yet possible in there, because unless they can modify it, that when a conventional fire alarm control panel is being actuated, it can also send a signal to a SIM card. So it is also possible, but as of today, it is a little harder for it to be realized. No? Now, the sense of taste is not possible as of this time. How would you affect a person to receive to respond to to stimuli and this sense of taste from a fire? So there's no technology yet on this. Only the present sense of hearing, sense of seeing, and a possible sense of feeling. Like I said, sense of smell is only through the inside the burning room. Those who are not inside the burning room will not be able to have this. So maybe later on when the fire is already very big. So now here let's analyze two slides which would explain the sequence of operation of a fire. So I mentioned this first slide as the life-saving process. So a smoke, fire detection, alarm, evacuation, life-saving process. So when a fire breaks, then it will develop smoke, or smoke develops, and smoke will be received by smoke detectors, and the detectors will actuate the fire alarm control panels, no? Or if extraordinary heat is detected by heat detectors, they will also send signal to your fire alarm control panel, and your FACP will send you a signal to your audiovisual alarm. And of course, this include ringer, buzzer, hotter, rotating beacon, and so on. And like I said, you can also include the smartwatch vibrator that I was mentioning earlier. And you can now actuate your stairwell pressurization so that the escape routes are pressurized. Okay, and then smoke extraction can also happen, so that therefore safe evacuation of people or humans from a building would become possible. The next slide is fire suppression. So after the life-saving process, now we have this fire suppression and life property saving process. So again, as usual, in a building that has an automatic fire sprinkler system, okay, your jockey pump is always running every now and then in order to pressurize the hydraulic system, meaning to say the sprinkler system of the building. So the jockey pump runs, and then when suddenly there is a fire, then the fire becomes big, builds up, and hits up a sprinkler that is just above the fire. The sprinkler will then operate because it works like a bimetallic nozzle, spray nozzle. So it hits up the sprinkler nozzle. The nozzle will start to sprinkler water, and then immediately when the water sprinklers, the pressure of water inside the hydraulic system, the sprinkler system, will drop rapidly. It will drop rapidly, and the sensor at the header near the fire pump will actuate the fire pump to start, no? So automatically the fire pump will start, and therefore the fire pump will deliver the fire water. At the initial point, the sprinkler nearest to the fire will just be the initiator. Will be the initiator. The moment it sprinklers, pressure drops, then the sensor in the system will determine this, so automatically will run the fire pump, and then of course the fire pump will continuously supply the fire water. Even if there will be more sprinklers that will operate, fire pump should be able to deliver the fire water. Okay, until of course fire trucks arrive, your firemen will help put up the fire. Okay, so the fire pump still operates even if the firemen arrive, not until they would be able to contain the fire, and therefore that's the time they will of course stop maybe the fire pump. Okay, if the fire is already under control, and of course the firemen will connect their hoses to the Siamese twin, or the fire department connection in front of the building. Okay, so that's how it is, no? The first slide is detection of a fire through a smoke, and then the actuation of the control panel to initiate an alarm, so that people, when they are alarmed, will run from the building to go out to save themselves. While in the second slide is this is for the fire pump or the sprinkler system to operate. Okay, so therefore the first slide is more of saving the people, the occupants of the building, while the second slide is more of saving the property, because the sprinklers, the water in the sprinklers cannot save a person, because if a person is still inside the building, and still there, chances are he will get suffocated, or he will be inhaling the toxic gas like the carbon monoxide and some others, and that will kill him. So therefore, it is therefore the fire detection and alarm system that is life-saving. And this sprinkler system is more of property saving, no? To prevent the fire from spreading, and of course from weakening the building. If the building is reinforced concrete, the thickness of the concrete that envelopes the reinforcing bars is only good for a certain number of hours. Okay, otherwise, when the fire continues, then it will weaken the concrete and eventually weaken the entire building. This is much more when you have steel. You have a building that is constructed of steel, and there is no provision of protecting the steel. Then when there is fire, your steel will become weak, become softened, no, by the heat of the fire. Do you remember the World Trade Center fire or accident in when was that, 2001, I think, 911, 911, September 11, was it? Anyway, so as you would see, the building after it caught fire, weakened, and then it collapsed. So with the second building in the World Trade Center. Okay, so fire consists of can be created if you have air, which contain oxygen, and you have a fuel, and of course you have a heat or a spark. So these are the three composition of fire. So if you don't have air, then you don't have fire. If you don't have heat or spark, you don't have fire. If you don't have fuel, then you don't have fire. So therefore, knowing these three, you could be able to formulate how you could probably prevent a fire. Okay, I just want to show you that this is a wrong installation, where in a gasoline station, the owner and the contractor and the designer allowed the installation of a panel board with circuit breakers very close to a gas dispensing unit. This is a violation of the code. No, you do not install breakers that are very close to sources of flammable substances like this dispensing unit of a gasoline station. No way. This is not possible. You know, this is a small player. I did not take any picture already of the name of this small player. If you take note of the gasoline stations of Shell, Caltex, and Petron, and even Total, they are made of higher level of safety or engineering or quality. No, not this small player. This is somewhere there in Taguig, along the East Service Road. I hope it is already corrected by the owner or the local building official of Taguig City. Okay, and it is a double whammy because again, this is another picture showing it. If you see, if the panel board is here above, you would see an outlet here below, and therefore it is much even closer to the gas dispenser. No? Okay, so it's a violation of the code, really. The engineer who signed the plans do not know his code. The one to supervise the project also doesn't know the code, and much more the building official, the inspector who allowed this to be done. So anyway, so let's make it as a lesson. Should not happen. It should not be done again in other parts of the country. Okay, so fire can be spread through convection, radiation, and conduction. And here is a more a clearer illustration of the three. Convection, so that's the direct and radiation. Okay, so darang, no? And conduction is can be transmitted by material, no? So therefore, this conduction is very important in order to prevent the spread of fire by having firewalls, no? Rated firewalls. Okay, so here are three ordinary combustibles. You have type A fire are caused by fuels like paper, cloth, wood, rubber, plastics, and they would require water to extinguish it. So it's they are labeled type A. And type B are those that are flammable substances including oil, gasoline, some paints like lacquer paints or paint thinner, grease, solvents, kerosene, LPG, and even natural gases like methane and so on, no? And letter C is electrical equipment fire. So when you have arc flash, when you have electricity that would jump from one line to the other, like a short circuit, then that is class C fire. And class C fire, you do not use water. Okay, for both type B and type C, you use extinguishing agents. Like for example, nitrogen can be used there, no? Argonite is also possible, and of course some special materials like FM200, uh, Novec, Energen, and some other inert gases. Okay, so now we go to part 2. Safe means of egress. So that means what is safe means of egress, or safe means of exit, or safe fire exits. That's what it means. Okay, so you know, you must have when you have this kind of a building very high, so you would see it's really very difficult to control the fire. So people must be provided with a safe means of egress, no? So you can imagine this kind of building get burning. You would think of probably using parachutes to save people. Huh? Can you provide for parachutes, or can you provide for helicopters to pick up people at the top of the building, or what else? So many things, huh? Because mostly people will run to the stairs, and they would scamper for safety from wherever they are in the building. If the fire is in the middle and a person is in the uppermost floors, they would run the risk of being exposed to this smoke. And smoke is carbon dioxide, and there is also the carbon monoxide that I'm mentioning, which would kill persons, no? Especially those that have some history of sickness. Okay, so you have to provide this kind of fire escapes, no? Very important. Open fire escape is still the easiest way for means of egress in case of fire, no? So that's why the Bureau of Fire people will always require a fire exit, because the moment you already come out of your window and go to here, then you are already exposed to fresh air. So even if the smoke is coming to your way, at least it will not be as devastating when you are inside a stairwell. When you are inside an enclosed stairwell and the smoke is so bad, oh, very dangerous. So you have to check on this when you inspect the minimum width of doors, no, for exits. 1.2 meters should be the minimum width of fire exits, and they must be provided with exit signs very clearly, okay, so that people would know where to run for safety. And of course there is the panic bar. The panic bar is when you push this bar here and the exit door will open. So this must be checked, test every now and then to make sure that the panic bars are working all right. And we should not allow putting this garbage or this storage or making the exit storage, no, it's not it is against the law. This must be kept open all the time, because when there is an emergency, these storage boxes will just slow down the movement of people exiting. Okay, and of course this one is another example of a violation. Should not allow this. Fire exit, do not block. It's there, but still people put basura, no, which is not good. No, okay. And outside must all be checked. If the inside should be clear, and then outside should also be clear. No, we should not allow garbage to be put in the fire exits, which may hamper the opening of the fire exit door. So we have to check our facilities with this. And like this one also, you would see the owner just put tables, no. Maybe they do not have the space, but they should clear this exit area. And exit doors should not be padlocked, should never be padlocked. Otherwise, you are just like imprisoning the people inside. When there is an emergency, you will not be able to go to and get the key anymore and open this. So people may die. And never would you allow parking just fronting exit doors like in this picture, no? So if it is an exit door, it's better to put barriers there, barriers mounted so that cars and other will not park on it, no? So not just simply fire exit, do not park. You must put bollards or barriers in there so that they will not park in front of the fire exit door. And of course, you have to install signages. Fire exit, do not block, emergency exit only, do not block, fire exit, whichever, no? And they must be very visible and installed plenty. Okay, so it should be analyzed where these signages must be located so that people inside the building would have a guide and where they will go to exit the building. Okay, and for a more detailed discussion of this, I refer you to what architect Edison Ching Padilla and architect Ferdinand Estepa has written in 2015. So this was the first edition, and the title is An Architect's Illustrated Guide to RA Republic Act 9514. 9514 is our Fire Code of the Philippines of 2008. Fire Code of the Philippines of 2008 and its implementing rule. Primer and means of egress. Okay, again, the authors are architect Edison Ching Padilla and architect Ferdinand B. Estepa. Architect Edison Ching Padilla is the incumbent building official of Valenzuela City. So he gave me this in 2017, November 2017, to Engineer William Juan. Practice fire safety, always enjoying hearing your talks and lectures. And signed, Architect Ching Padilla. So I'm very thankful that Architect Ching Padilla has also been doing lectures at the MEP Center before, and he continued to advocate. He is a colleague in the lectures in the capacity building of the PWH, Office of the Building Official. I mean, the Philippine Association of Building Officials usually conduct this capacity building for their inspectors and building officials, and Architect Padilla is the speaker for fire means of egress or fire, and yours truly is the usual speaker in electrical regulations. Now we proceed to fire detection and alarm systems, which like I mentioned, this is the system that would save lives, including the toxic gas detection and extraction. So, uh, uh, FDAS is mandatory, should be, not only in buildings. In buildings, about 97% of commercial buildings has this, but homes only 17% has. So again, my suggestion for the Bureau of Fire and the Office of the Building Official is to come out with an IRR that should expand the implementation of the FDAS not only for the buildings or commercial buildings, but also for the homes. Okay, also for the homes. Okay, so anyway, what are fire detection alarm systems? Detect fire on the areas, notify building occupants, summon organized assistance to initiate control, initiate automatic fire control and suppression like sprinklers, supervise fire control and suppression system to assure operational status, and so on. Systems may incorporate one of all of these functions. So that's, and FDAS, fire detection and alarm, includes this block diagram where you have the original here, a smoke detector, then heat detector here, and a manual pull station, meaning just a, a push button station. When you break that center and then you push it, then you are actuating an alarm. Oh. So this one is a manual thing, this red box here, red rectangle. But this one, smoke detector, is an automatic thing together with this heat detector. They are both automatic. The moment they detect smoke or heat, they give this signal to this center equipment here or box, which is the control panel. And the control panel, since it is a logic device, will send a signal to your buzzer and light and hoter or whatever to actuate an alarm. And even you can also automatically operate smoke extraction, air pressurization, and others. No, of course, here I have included in my suggestion the provision of toxic gas detectors, which is my baby, like I said. No, carbon monoxide, hydrogen sulfide, which of these two are toxic gases, and LPG is highly flammable, and of course CH4 is methane, highly flammable. So this must be provided. These detectors must be provided so that we can ensure higher level of safety for our buildings and facilities. Okay, so here are the criteria. So I will not discuss it to detail anymore. Anyway, any one of you will be interested to get a copy of the PowerPoint, just send in a request to me via email so that I can send you. Okay, and of course, just go through it if you're designing the FDAS so that you can do it correctly. Okay, and here is an important thing. The number of smoke or heat detectors is could be governed by this. For detectors in general application, up to a maximum of 40 square meters room, one detector, meaning one. You can put two, but at least there should be one. But for special rooms, like room with equipment like control rooms, electronic cubicle room, computer room, battery room, electrical room, switchgear room, and so on and so forth, they should be provided in every 25 square meter of area. So that means that if it is a 50 square meter area, you should have minimum of 2 detectors. If you have 100 square meter of area of this control room or cubicle room, computer room, then you must have at least 4 detectors. Okay, so that's the minimum requirements, and that's, of course, that's the minimum. You can add more if you want to ensure that it is greater safety or means of detection of the smoke or heat to ensure safety. Okay, so there are 2 types of fire detection and alarm system. One is the conventional type, and the other one is the addressable type. The difference between the two is that the conventional type is an analog system, analog system. So that it works like on a switching, like ordinary relays and ordinary switches. Okay, while the addressable type works with computers, so it has a central processing units, it has a video monitor, and the detectors are all um, using digital communications, and there is the binary system that is being used between the detector and the computer system. So you cannot use components in a conventional system to an addressable system, or similarly, you cannot use components in an addressable type like detectors and output devices in a conventional system. They will not work. Okay, conventional. So between the conventional and the addressable type, they are just simply the same. Oh. Except that, like I said, the addressable type has a computer, and this one doesn't have a computer. This conventional. Of course, conventional is a lot cheaper than the addressable type. Okay, so for a for a four-story building, which would have maximum of 8 zones, the cost of the fire alarm control panel for the conventional would be something like 100,000. But for a an addressable type, for that equivalent could cost 60,000 more, so 160,000. So something like that, something like that. So of course, the addressable type is now being used for bigger buildings like malls and high-rise and so on, because it has the capacity to provide a more accurate protection, no, safety and protection for your occupants. Okay, so here is a general requirements for conventional FDAS. Okay, I'll not discuss in detail. And here is for an addressable. As you will see, the applications are more like industrial and non-industrial buildings, institutional buildings like hospitals and so on, residential apartments, so high-rise, hotel and hospitals, all industries, malls and multi-story complexes. So when you say complex, it's a mixed use, offices and control rooms. So there are more areas where this addressable type is being used. And like I said, the addressable type uses a microprocessor or a CPU. Okay, and benefits of the FDAS addressable type are mentioned in here. Continuous supervision of the devices, discrimination between a false fire and a real fire, and then individual detector addressing or communicating capability, detection of over and under sensitive detectors, pre-alarm case of any detector. Meaning to say, if one detector is defective, then it can do an alarm. While in the conventional, you will never be able to know it, not until you're going to test it, actual test, and it's not functioning. No? And facility shall be provided for alteration program, so it can easily be maintained, because you can the CPU, the central processing unit, or the computer, can be made to communicate with the different components in the system. No, okay. And here is one of the input devices, the manual police station. At a closer look, there is a glass here, which you have to break in case of emergency and push the button so that it will cause a switching and it will actuate an alarm. And of course, you have the other automatic devices like the heat and the smoke detectors. Here, heat detectors, smoke detectors, and you also have flame detectors. Of course, flame detectors, it's already late. This is already flame. Your heat detector is much better and than the smoke detectors, because the heat detector, before you have a fire, it detects already the presence of an abnormal heat that may be happening inside the room. No, and smoke, there is already a fire in here. No, flame is worse because it's already a big flame. Okay, fire gas detector is the same. You already have a gas, so you must have something like a toxic gas detector, no? Okay, so here are just the description for the heat detector, no? Fixed temperature type and rate of rise heat detector. Okay, and now we go to the photoelectric detector. So smoke detector, photoelectric in nature. This is the most common detector. And the ionization smoke detector. So a little difference in the operating characteristics. The ionization is more, it's a lot more expensive, but it is more, uh, uh, it's more, what you call this, uh, sometimes suited best more for some addressable applications, no? And then of course the output devices like audible alarms. You have sirens, bells, buzzers, horns, voice drivers. So these are all sounds, sound alarms. Okay, an audible alarm signal lets people know the alarm system has been activated. Devices may be mounted inside or outside based on level of protection required. Okay, and the next one is visual. So this one is the sense of hearing, and this one is the sense of seeing that I told you. So a visual signal lets users know the status of the alarm system if activated. Visual devices may be mounted inside or outside. May it consist of strobe lights, so it's and LED lights, strong LED lights, on and off printer. What else? Rotating beacon. A rotating beacon is the one that is installed on top of the police car. A rotating light. Okay, and this was the one that I mentioned regarding a smartwatch system, similar to this. So this watch has a SIM card inside, and it could receive a signal from a computer or from a fire alarm and control panel that is addressable type, and it would vibrate. Of course, you can also use your smartphones because the smartphones has a SIM card, so your addressable type or your CPU in the addressable type will also send a signal to your smartphone. But the problem is we do not usually have our smartphones in our pocket when we sleep. So my suggestion is to use smartwatches, which many of us would wear when we sleep, no? Although some of us would remove it, but when you have this, and you have that protection in the building, of course you have to wear it because you will have a higher level of protection, no? Like I said, you have already the sense of hearing by the alarms, and then the sense of seeing by the lights, and the sense of feeling by the vibration that this could produce. Okay? Now we have these codes that govern the practice of or the provisions of FDAS, Fire Code of the Philippines 2008, and then Philippine Electrical Code Part 1, Philippine Electronics Code Book 2, FDAS, NFPA 72, National Fire Alarm and Signal Code, Signaling Code of the US, UL, Underwriters Laboratories, and other standards, worldwide standards. And these are just abbreviation for that you may see in typical FDAS plan. You have FACP, meaning to say Fire Alarm Control Panel. RAP, meaning to say Remote Annunciator Panel. SD means Smoke Detector. FD means Flame Detector. MPS means Manual Pull Station. SS means Supervisory Switch. SL means Strobe Light. EOL means End of Line. This is the resistor that is connected in the circuit of the smoke detectors. And UV means ultraviolet light. CONV is conventional, and HD means heat detector. FGD means fire gas detector. FS means flow switch. FAC means fire alarm cabinet. AV means alarm bell. CP means call point, so there's a phone there that is provided. IR means infrared light. And ADD means addressable. So this is the difference between the conventional and the addressable type fire alarm control panel. And here is just a typical circuit, how an FDAS circuit would be shown. So you have here a layout of a floor plan. And you have here rooms. So this is one room, a bedroom, 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 bedroom. So there are two units, two bedroom here, and there is this sala. This is the living room and a kitchen, dining and kitchen area, and two bedrooms. And then you would have smoke detectors interconnecting this, here, here. All of these circles are smoke detectors. This one, this one, and this one, and this one, and of course, this symbol here, green symbol, is a the fire alarm control panel, and you will see a buzzer here, a bell and a buzzer to initiate the alarm. Okay, so that's the usual plan, and to show the vertical riser, you would show like this, a one-line diagram showing here. These circles are the smoke detectors on the second floor, and here are the smoke detectors on the ground floor. And fire alarm cabinet here, and here you have a remote annunciator panel here, and of course the buzzer, and here is the fire alarm control panel. So that's for a two-story building. For a higher building, you would show it like this. Say for example, you have three-story building. This is ground floor, and this is mezzanine, and this is second floor, and this is third floor. Or if you have more floors like fourth, fifth, sixth, and so on and so forth, you just simply indicate the risers. Okay, and again here you have SD here, smoke detectors, and of course all the other components that we have indicated earlier, including the schedule of wires, symbols, notes, construction notes. Okay, and again that's how it's being presented. So we have done already the fire detection and alarm system. We go to this next topic, which is my baby, like I said, toxic gas detection and extraction. But before we continue on, let's have a short break. Okay, we are back. Let me greet those on the chat box for a few moments. We have here John Docos again. Good evening, Sir Will. Good evening. And London Sisters Channel. Good evening, sir. Charles August from Zambales. Good evening, sir. Pwede po ba makahingi ng copy nitong person? Yes, of course. JCG. Good evening po, sir. And Lino Hernandez is also here. Good evening, Lino. How are you? And then, of course, Ten Apolinario. Good evening, sir. Willie. Then Richard Regidor is also here. Good evening, Sir Will. Then, okay. So, thank you. Just post your questions that we'll try to answer as we go on later. So, now we proceed with my baby. I always say it's my baby because after the incident of the Research World incident in 2017 in June, in just a few months, I have established that the reason for that for the for the death of about 37 people was the poisoning due to carbon monoxide. So let's go back. Programmable, flammable gas sensors to prevent possible explosion or fires. Fire gas detectors monitors level of carbon dioxide and carbon monoxide, and they are common to all fires, especially inside enclosed spaces. More discriminating than other detectors, can be designed to be sensitive only to gases produced by specific types or hostile fires, and ignores gases produced by friendly fires. Not many in use, very specialized applications. So you see, in the world, these carbon monoxide or toxic gases are only a few, and that's why many of our buildings are not yet provided with this, and that's why I'm saying it. That's my baby because I'm trying to awaken the Bureau of Fire people and the Office of the Building Official, the LGUs, that we should now upgrade the implementing role of the Fire Code of the Philippines to include already this toxic gas detection and extraction that I'm talking about. That it should already become mandatory. Okay. And now again we discuss about carbon monoxide. Carbon monoxide is a colorless. Take note, carbon monoxide is colorless, odorless, tasteless, flammable, toxic or poisonous gas, and is slightly lighter than air. No, so do not make a mistake of thinking that it is carbon dioxide. Carbon dioxide is the one we exhale. When you exhale, we bring out carbon dioxide, and the plants need the carbon dioxide. Okay. While the plants also give back the oxygen that we breathe. But carbon monoxide is 1 part oxygen. In carbon dioxide, you have CO2. No? So there's 2 parts oxygen in there. 1 part carbon and 2 parts oxygen. While in carbon monoxide, you have 1 part carbon and 1 part oxygen. And that makes it poisonous or toxic. Okay? So, carbon monoxide is produced during fires in enclosed areas. So, if you have a fire inside air-conditioned rooms, enclosed rooms, then chances are you produce this carbon monoxide. Okay, it is present in enclosed or partially enclosed buildings. When there is not enough oxygen inside and there is a parked vehicle running, chances are you also produce carbon monoxide. So what is the solution to this? You must have detectors. This is the only way, no? We must have carbon monoxide detector, and they should actuate an alarm, and they should run automatic extraction fan or exhaust fan or ventilating fan, so that this carbon monoxide will be flushed out from the room. Can a person smell it? Like I said, it's colorless and odorless. So only a detector, carbon monoxide detector, can detect it. Okay? Otherwise, then if you do not provide for this, then more people will die if there is a fire in an enclosed area. Of course, if the fire happens in an open area, chances are the carbon monoxide that is produced is very small. Not really a big problem. Okay? Maybe it's more of the smoke, the bad odor of the smoke that may affect those people inside a burning building, but it is not totally enclosed, no? When I mean totally enclosed, those buildings like the Araneta Coliseum, the Mall of Asia Arena, you have the SMX Convention Centers, you have the Terminal 3 in NAIA, Terminal 2 in NAIA, even the Terminal 4. or Terminal 1, all of these are enclosed spaces. Theaters, mga sinehan, convention rooms, conference rooms. So, even a small room, no? If there is a fire, then chances are if you remember the fire that killed the daughter of the former speaker, no? It was a house in Forbes, air condition, and when fire broke out, I think it was the Christmas lights, something wrong with the Christmas lights, the quality maybe. So then it produced carbon monoxide because the house is air conditioned. And the child ran for safety to one of the rooms upstairs. Unknowingly, the carbon monoxide was continuously being produced by the burning. Okay? And then the carbon monoxide would then follow her to the bathroom where she took shelter, no? So there. If the house would not have been air conditioned, no? If it is just simply open, then chances are there would be lesser chance for producing the carbon monoxide. So that's the problem. If you have an air conditioned room and it is totally sealed, big danger. If there is a fire, chances are you produce carbon monoxide. But if there is a little awang-awang, that means air can come in and go out. But of course, you will lose cold air. We don't want to lose the cold air, so we want our air conditioned rooms to be very tight. So that's the big problem. So the only way is you must have a detector that will sound an alarm and run exhaust fans. No, that's the only way. There's no way for it to solve this problem. Okay. So this is my explanation. I will not discuss it anymore. You can just read it later. Now we proceed with hydrogen sulfide. So I'm talking about toxic gases. Now the second one is hydrogen sulfide, very dangerous also. How is this produced? Well, the hydrogen sulfide comes from gas from the septic. No, a hydrogen sulfide is colorless, corrosive, flammable, toxic, or poisonous gas. Take note. It is colorless, corrosive, flammable, toxic gas. Of course, it is not without a smell. As a matter of fact, it is with a bad smell. No? Mabaho. It smells of a rotten egg. So when you smell this rotten egg, then there is hydrogen sulfide. And of course, one thing good is that it is slightly heavier than air, just like LPG, just like methane. They are heavier than air, so they occupy a space nearer to the floor, no, not to the level of our nose. But of course, they may be there if there is plenty of it produced, just like what happened with the Glorieta 2 explosion years ago, 2007 or 2006? Okay, so the basement floor, they have bathrooms in there, or restroom. The sump pumps were not properly maintained, so they produce methane and hydrogen sulfide, which caused the explosion. So hydrogen sulfide is present from natural gas, no? So also in LPG, also in crude oil, also in the refinery, in the septic tank, there is there. So therefore, in the home, there is a possibility that it can enter the home when the trap seal in the plumbing system is lost. No, so meaning say the water inside the P-traps are lost, or in the floor drains the water is lost there due to evaporation. Then you run the risk of creating this poisoning coming from the hydrogen sulfide. But one thing good, like I said, is that may smell siya. There is a bad smell which should sound a person, should give an alarm to a person. But the big problem is, even if you can smell it, that will take a little longer time for you to be able to smell it, because our nose are located higher. No, if only our nose is there is also a sensor in our feet. Meaning to say, if the feet is provided with a sense of smelling, so that it could detect the presence of this poisonous gas as low as which is close to the floor, then that would be a lot better, no? But God only gave us the nose in our head. Unless you are lying down, you are lying on the floor, very close to the floor, or prone to the floor, then your nose is near the floor, then you can easily smell this heavier than air, no? Slightly heavier than air. Okay, just like LPG, methane, hydrogen sulfide, all of these three gases are heavier than air. Okay, an example of hydrogen sulfide gas that is being vented to the atmosphere, no? So in the gasoline station, they provide these vents so that the hydrogen sulfide would just be diffused through the top of the vents, no? That's how it is being vented to the atmosphere. Okay, LPG is also a dangerous gas, so it must be provided with a detector. Here is a detector, and here is a solenoid valve, an electrical solenoid valve that will automatically shut off the flow of LPG gas to an appliance like a LPG burner, okay, or maybe a dryer for a laundry or other purposes. Okay, so, and here is methane. The characteristics of methane is also similar to LPG, highly flammable, but not toxic. Remember, LPG and methane are not toxic gases, but they are highly flammable. Take note, highly flammable. So the moment you create an ignition, then pop, suddenly you would have a big explosion. And this is the same cause of the fire at the Glorieta. Okay, while the fire at or the explosion that happened in the Serendra was caused by LPG gas leak at the Serendra in Bonifacio Global City near the market. Methane gas was the reason for the explosion at the Glorieta 2 in 2006. And here is my illustration on how to protect against these gases. So you must have CO2 detector. This one is the CO2 detector, and this is your H2S, methane, and similar LPG detector. And of course, you have to provide this carbon monoxide toxic gas extraction fan. So these fans, extraction fans, must be installed at the ceiling, must be mounted on the ceiling. And like I said, when the detector detects it, it will send a signal to the fire alarm control panel or your logic device, and the logic device will send signal for the extraction fan to run or operate, so that it will remove the toxic gases from inside the room or from inside the enclosed space. Okay, so that's how we should solve this problem on toxic gas detection and extraction. So part 3C is smoke extraction. Okay, let me just go to the chat box. Maybe some have some questions already. Marlon Pascual, good evening, sir. Marlon. Ed B, good evening, Sir Will. Then Richard, I believe, sir, that others are not yet adopting the flammable toxic gas detector since it is more expensive than the ordinary smoke detectors, which are, of course, the main requirements of the fire code. Yeah, as I was mentioning, Richard, no, the the simplest that we are providing as of today in our design is the smoke detectors and the heat detectors. But I'm talking about what happened in Glorieta 2. I'm talking about what happened in Serendra and some other, no, and also what happened at the Resorts World before, because there are no detectors yet provided. People die, no. Resorts World fire incident, 37 people die. In the Davao uh, mall fire in December 2017, same. You know, all of those fires, Manor fire, the ozone disco, and all of those fires, the death there were caused by carbon monoxide. No? Carbon monoxide. Because most of these are enclosed. In the ozone is an air-conditioned place. So it was carbon monoxide. So with Manor is a hotel. So the hotel rooms are air-conditioned. See? So lung center is also air-conditioned. So, you know. So all of this, if you do not provide for this carbon monoxide detector, if a fire happens, then many people will die. Those who are of weaker physical condition, like those people who have emphysema, they have lung problem, you have hika, asthma, or maybe those that are high blood, have difficulty in breathing or running or what, they are the candidates. And of course, even the pregnant women, even the children who may be there in the building will have difficulty running, because the stronger ones will have a greater chance of saving themselves. The stronger one, the more athletic people will be able to run and go to the fire exits. But how about the pregnant women? How about the young people, the young boys or girls that are living inside them? How about those that have sickness? The old people. So they will become candidates. Now, if you provide this detection and extraction automatically, at least as they are still trying to leave the room on a slow space, slow pace, slowly, at least they will not be exposed to the carbon monoxide poisoning. And if you detect a toxic gas like hydrogen sulfide, you will be able to remove it from inside, no? Or if you have a flammable gas like methane, you'll be able to alarm and bring it out. So therefore, if you provide this toxic gas detection and extraction that I'm talking about, then, or make it mandatory, then you will be able to increase the level of safety of your buildings. Okay? So let's just analyze what is the standards of Europe, no? So in Europe, they would just simply provide for smoke extraction. So take note, they indicate smoke to be extracted, and they do not mention anything on toxic gas. There's no written thing here about toxic gas. Of course, they have air pressurization, they have fire resisting damper, they have smoke exhaust fan, they have smoke damper, but there is no mention of carbon monoxide or toxic gas. See? Same with this. Positive pressure ventilation. So we're talking about air pressurization of the stairwell, and there is extraction inside the room. So it doesn't mention of carbon monoxide. None of them. So with this is an American drawing, which I was able to check on the internet. But there is none. No carbon monoxide mentioned. They just mentioned smoke here. Smoke exhaust. Supply fan. So smoke detectors. But there is no carbon monoxide detector. Okay, so it has been already 2 years since I started to advocate for this. That was something like August of 2017 when I started to talk about this carbon monoxide detector. Okay, so parking areas should also be provided with carbon monoxide detector with exhaust fan. So here are 2 exhaust fan on this side, and there is also 2 exhaust fan on the other side. So these 2 here on the left side will be blowing in fresh air inside, and this will be bringing out the air inside the parking area. That is when you have cars parked that are running and there's not enough oxygen or air inside. So you produce carbon monoxide. And a lesson in the Kentex fire is this, no? Take note, especially those who are architects. You would take note that the ridge, the apex of the building, of the Kentex building factory, is without a ventilation. You take note of this blue colored roof here. There is a ventilator on the top. This one. And so with this building, there is a vent. And so with this maroon colored building at the back, it has a vent. But this building doesn't have a vent. So this building and the Kentex buildings do not have vents. So my point is, if you have this vent, or these buildings that have vents, if you have this vent, chances are your carbon monoxide that may be produced when there is this fire will come out of these vents, and therefore reducing the chances of people being poisoned inside. The reason why so many people died in the Kentex fire is because of this. No ventilation on the roofs. Take note, this one, no vent. Both the Kentex building or warehouse building, factory building do not have the vents. So that's my suggestion for architects to provide this vent, for contractors, and for owners, and of course for the building officials also to take note of this requirement, that as much as possible we should provide this vent, so that in case of fire, chances are you will allow the smoke, which is carbon monoxide, to come out of this. Remember, carbon monoxide is lighter than air. Okay. And here's a picture of the ground floor of the Kentex factory building. The fire started here. There is flammable materials here stored, caught fire, and then the wind was coming inside the warehouse, so suffocating the people inside the factory building. Okay, so even this kind of warehouse should also be provided with exhaust fan, like this one, exhaust ventilators, so that if there is fire, you will be able to suck out the smoke. At least the people inside your warehouse will be able to run for safety. Okay. So now we've done through with toxic gas detection and extraction, as well as smoke extraction. Now we proceed with the next topic, air pressurization. The fire exits must be assured to be safe for people to run through, to exit through, in order that the people who will be running for their safety to the fire exits will have a greater chance of not being suffocated. No? So here is a picture of a stairwell exhaust fan. A pressurization fan. It's not an exhaust fan. It is a fan that would get fresh air from outside of the building and put it inside the stairwell, the top of the stairwell. So here is another drawing. So you have the fan here, the stairwell fan here at the top, and when it operates, it would bring in air to inside the stairwell. No? So if you have a stairwell that is not if you have a stairwell that is enclosed, so you must have this variable. You have this fan, stairwell fan, that would increase the pressure inside, so that the smoke from the rooms would not come out and will not go to the stairwell, and therefore the people running out of those burning rooms will be able to exit much easier, no, than when you don't have this. Because if you don't have this, definitely the smoke will come out of the exit door and it will suffocate the people escaping from the burning room. Okay? So that's stairwell pressurization, or also known as NFPA 92. And of course, today, with the technology of inverter control, this motor now uses this variable frequency drive. Okay, no longer using the across the line or full voltage motor run or the Y delta run. No more. You have to use this variable frequency controller. Okay, and here is a way to size it up. I already indicated in a for a 22-story building. I mean not a 22, 11-story building. The calculated value of the fan, capacity of the fan is CFM, is 24,278, and the fan was selected at 29,000 cubic feet per minute, and it is driven by a 15 horsepower motor and controlled by variable frequency drive. Okay, so the pressurization fan maintains something like 3 to 5 psi pressure, a little higher than the pressure inside the burning room. Okay, now we go to fire extinguishing agents. So after we talk of the fire exits, we talk of the smoke detection and heat detection, then we talk of toxic gas detection, and then we talk of the air pressurization of the escape routes. Now we go to extinguishing means, no? So we'll start with the agents. So agents, there are so many agents available today. Of course, that's a little bit more expensive. Water is the cheapest extinguishing agent. It is readily available. Okay, extinguishing agents, substance contained in portable fire extinguishers that puts out a fire. Various chemicals are used, including water. It is the best agent, no? For a particular hazard, depends on several factors. Types of materials involved, anticipated size of the fire. So, depending on this, you would use different kinds of agents. Fire safety is very important. So, different fires require different extinguishing agents. Water used in Class A only removes heat. In dry chemical used on Type A, Type B, Type C inhibits chemical reaction. And then wet chemical is developed specifically for use on Class K fires. Extinguishes fire by forming soapy foam blanket over burning liquid and cooling temps to below its ignition point. Can sometimes be used in Class B and Class C fires. Then carbon dioxide used on B or C removes oxygen from the fire, ineffective on Class A fires because the fire can continue to smolder and possibly reignite. Also, the high pressure discharge can cause the burning materials to scatter with a Class A fire. Then you have halogenated or clean agent, used mainly for Class C fires, but also can be used for Class A and Class B fires as well. These types of extinguishers also remove oxygen in the air. Then here is a yellow colored fire extinguisher. Fire extinguisher of types: combustible metal, Class D fires, two primary extinguishing agents, sodium chloride and copper-based dry powder. Extinguishes by smoldering burning materials, 6 to 8 feet maximum effective range. So because of the heat is so hot, is so dangerous, you have to be far from the fire. Okay, the metal fire. Okay. Then fire extinguisher types: wet chemical uses potassium acetate as the extinguishing agent. Extinguishes by cooling and forming foam blanket to prevent reignition. 40 seconds discharge time, 10 to 12 feet maximum effective range, so it's a little farther than the yellow one earlier. On a Class K fires, don't use until after mixed extinguishing system has activated. So there are some conditions on its use. Clean agent fire. So definition is fire suppression system whose means of extinguishment does not cause damage in addition to that which was caused by the fire itself. Okay, and here is the illustration for the application of the FM200. You know, when I was a young engineer, there was this halon, HALON. But it was found out that this substance halon is producing effects detrimental to the ozone layer. So eventually, it was banned because of this. And today, it is replaced by this FM200. Okay, so here you have these two cylinders as the agent cylinder, agent storage containers, these ones. And you have their piping here, the orange piping, and you would have the nozzles here. 4 nozzles, discharge nozzles, 1, 2, 3, and 4. So equally spaced on top of the room that should be protected. You will notice that there are fire detectors. This one, this one, this one, and this one. And they would send a signal to your control panel which would automatically allow the flow of the discharge of the agent. Okay. Enclosure pressure venting. There's also the equipment shutdown, HVAC shutdown, building fire alarm, and dedicated controls. Okay, so that's how this FM200 operates. Similar to Energen also and Novec. Almost similar. So the FM200 fire suppression is described as fire suppression is also known as HFC227. It is a waterless fire protection system. It is discharged in the wrist within 10 seconds and suppresses the fire immediately. FM200 fire suppression is found as an active compound, as a propellant in medical inhalers. This goes without saying that FM200 gas is extremely safe for occupied spaces with the correct fire suppression design. There is a common misconception that FM200 gas reduces oxygen. This is not true. FM200 is synthetic chemical fire suppression gas and extinguishes a fire by removing the free radicals or heat elements from the fire triangle. That means the oxygen, heat, and fuel. And here is a picture of how this FM200 look like. Okay. And here is another illustration also. Here is the FM200 source, and with piping. What piping would they use? My suggestion is for you to use BI piping, black iron pipe, or mild steel pipe. Okay. And here is another illustration of how it operates with all the nozzles spewing the gas. And another kitchen showing the agents. And these tanks here are the agents. And in electrical, usually switch gears, control panels, and switch gears, electrical switchboards can be provided with the necessary piping to the different components, so that the moment you detect fire, this gas would be spewed in the area and would put off the fire very fast. Here is another installation where you have a switch gear, and you would have you would have the agent in here with the piping. So that means the piping goes inside the switchgear, and therefore it would protect your switchgear from against burning. So in a control room where you have control desk console like this, you can also provide this type of protection with nozzles on both sides. So this to protect your equipment the moment there is a heat or a fire or a knock flash that may happen, then it would operate immediately. Okay, next. And as an alternate to the FM200, you have here Novec. Novec is, I think, a product of 3M. 3M, I think. Let me see. Okay. 3M Novec. Yeah, correct. 3M is the one that produced this. You know, 3M, the popular 3M, no? Novec 1230 Fire Protection Fluid is a next generation halon alternative offering outstanding performance, large margin of safety, and an excellent environmental profile. Zero ozone depletion potential, no, not like in the halon. 5-day atmospheric lifetime. Global warming potential of 1. A large margin of safety for occupied spaces. Novec 1230 Fire Protection Fluid is based on a proprietary chemical from 3M called fluoroketone. The full chemical name for this compound is dodecafluoro-2-methylpentan -3-1. It's Australian nomenclature. The way it is designated in the NFPA 2001 and ISO 14520 Clean Agent Standards is FK-5-1-12. Novec 1230 fluid offers a unique combination of safety, low environmental impact, and extinguishing performance, making it the first chemical halon replacement to offer viable, long-term, sustainable technology for spatial hazards fire protection. So now we have the, as a replacement to the halon, we have the FM200 and now the Novec. Okay. And here is a sample of installation of the Novec. The brand is Kide Fire System. So you would see the agent tank and the piping here, okay, supplying to the switchgear. Clean agent fire suppression. Energen is a third one. Energen is a product of OneSol Corporation. Is composed of 3 gases, 52% nitrogen, 40% argon, 8% carbon dioxide. Energen systems reduce the level of oxygen to about 12.5%, which is sufficient for human safety, but not sufficient to sustain fire. So that's how this Energen works, no? And here is a picture of that argon gas or argonite gas, which is also inert gas. And here is a tabulation matrix prepared by Siemens showing some of the different agents. Let's take a look at them. Well, before we proceed, let me go back to the chat box. Again, I'm not feeling so well, ladies and gentlemen. Anyway, Mark Ramsey is here. Good evening. Your Yuri Taraki, how about oxy reduction? Oxygen reduction? Yes, it can be. But oxygen, if you have a person inside the room and you reduce the oxygen, then there is the danger. Okay? So, Yuri Taraki, we have Novec 1230 fire suppression in our substation. Very good. Where is that substation, Yuri Taraki? Please mention it. So, That will be for the reference of everyone. Okay. Now we go back. So let's just see what Siemens has done to compare all these clean agents and inert gases. So it mentioned here as first is FM200. No, stored pressure is 360 psi. Safety factor is 28%. Gross weight, I think, no. And then most common key benefits. Most common, easy to obtain service, low pressure. Then disadvantage, damage to the environment. So Siemens says that FM200 damages the environment. Okay. Let's see, Novec. Novec is produced by 3M. So 360 psi, 112 safety factor. GWP is 1. Then wide safety margin, good for environment, and it is low pressure. Since 3M only introduced it in 2003, it is relatively new. Okay. ECAR or FE25, 609 psi, so very high. Minus 22% factor, 2,800 for GWP. Less agent required, maybe a drop in replacement of halon. Maybe a drop in the replacement of halon. So it says it is a possible replacement. Then dangerous to humans, maybe outlawed again. Oh my God! So this is an X. So dangerous to humans. Okay, let's go to FE13. Maybe it's almost the same with this ECAR, no? 609, 67, 11,700. Very effective. Key disadvantage, not typically used for occupied areas, not good for environment. So this is also no good. Energen, 2,900 psi, so very, very high pressure. Safety factor is 10. 0 GWP. Good for environment, close to atmospheric density. 60-second discharge time, so 1 minute. 40% volume added to room, up to 10%, up to 10 times as many cylinders. So very bulky. So you need so many cylinders. Okay. Okay, that's Energen. Argonite, same pressure, 13%, same as above, and easier to refill than Energen. Same as above, and new 180-degree nozzles. Oh my God! So same as, so because Energen is also argonite. Carbon dioxide. This is 2,900 psi. It is lethal because it totally displaces oxygen. Very effective, easy to refill. Not permitted to use in occupied areas. So like I said, if you have occupied areas, if you have people working inside the rooms, then you do not like CO2. Okay. So what is then is the best? Let us review again. FM200, damage the environment. Novec, fairly new, but it seems there's no negative. Ecaro, dangerous to humans. FE13, same. Energen, 60-second discharge time, 40 more volume added, up to 10%, so it's very big, 10%. So same as above. Oh my God. So it seems like Novec, although it is fairly new, is the one that is with no negative remarks by Siemens. I remember 3M is an American company and Siemens is a German company. So, do they have any relations? Anyway, that is how Siemens interprets the performance of these gases. So it says Novec is much better. No, wide safety margin, good for environment, low pressure. Okay. So nitrogen gas can also be used. The air is 80% nitrogen roughly and 20% oxygen. Okay, so therefore nitrogen is plenty in the atmosphere. So you just need to produce nitrogen gas. You can also have an equipment that can produce nitrogen at site, no? In other words, near the place of application, you can produce this equipment that can produce nitrogen, which can already be injected to your room. But of course, it must be not occupied, because the moment you introduce plenty of oxygen inside the room, then you are displacing oxygen. Okay? Why is fire extinguished with nitrogen? Continuous combustion requires more than 15% of oxygen concentration by volume. The NN100 system will suppress a fire by reducing the oxygen concentration down to 12.5% with nitrogen gas discharge. Let us see this, no? So this is the NN100 system that it mentions. It's a means of processing, no? So it is a system that produces nitrogen from air. So take note here, you have air compression, then air treatment, then you have absorption, separation, and then here now you have nitrogen accumulation, and then the nitrogen is injected to your switchgear or equipment. So it produces this system, 95% nitrogen. Now available is the new and more economical technology for fire suppression, the use of in situ production of nitrogen gas for fire protection systems, an alternative to fire water sprinkler systems and to the expensive FM200 Novec or Energen system. This system is fairly new. Of course, nitrogen is included in those. It is included in the Novec, included in the FM200, and included in the Energen. But if you compare the prices of FM200, Novec, and Energen, they are very expensive. What this slide is mentioning is you can have this equipment that now operates so that it will produce 95% nitrogen, just simply getting it from the air. See, the feed is 21% oxygen, 79% nitrogen. Okay, so this is good for call centers, business process outsourcing, avoiding damage on PCs and other electronic equipment rather than the conventional water sprinkler system. Okay. So nitrogen is also used to reduce corrosion inside BI pipes. So that is when you inject nitrogen inside your hydraulic system. Okay, so those are the agents, starting with FM200, then Novec, and then Energen, and then you mentioned about nitrogen, and of course there was this mention of carbon dioxide, but of course it has some problems. Okay, so far there are two good agents, the Novec, which is very expensive, and this nitrogen in situ, no, at site, so you can have this, no. Okay, so now we go to automatic fire sprinkler system, NFPA 13. This was originally prepared by Engineer Henry Suarez, also a registered master plumber and a professional mechanical engineer, and I modified it to make it more updated. So now our references are the NFPA was organized in 1896. So that was the time when our forefathers was tearing their cedula. Remember August 1896, the cry of Pugad Lawin happened, and that was the time that America already established the NFPA. Then we have the factory manual, organized in 1835. Factory manual is an organization of insurers established in 1835, no? And then you have UL, Underwriters Laboratories, a non-profit organization founded in 1894. So that was the time when our forefathers were still, when Rizal and the rest of our national heroes were uh, preparing to uh, gain independence from Spain. Okay, definition of terms: fire pump, then jockey pump. Fire pump is a firefighting equipment or apparatus usually connected to the fire protection piping system, provided with dedicated source of steady water supply. Then jockey pump is a small pump, usually every now and then running to maintain the pressure in the hydraulic system. So usually a jockey pump is about 1/10 of the size of the calculated or the selected fire pump. Okay? So if your fire pump is 50 horsepower, chances are your jockey pump is about 5 horsepower or even less. Okay, here are the standards. Fire Code of the Philippines 9514 2008, enacted in 2008. And the National Building Code, you have the Philippines Society of Mechanical Engineers Code, Uniform Mechanical Code, NFPA, Philippine Electrical Code, National Electrical Code, and so on and so forth. So there are two approaches to fire protection. One is passive, the other one is active. Active means the use of sprinklers, the use of fire pumps, jockey pumps, fire hose cabinets, or anything that is introduced to the building. Something like a piping or a mechanical. Even the fire hose cabinets or even the fire department connection or the Siamese twin, the pipes and so on, are part of the number 2 or active. No. How about passive? What is passive? Passive are the materials that are used in the building. Like for example, when you use concrete hollow blocks, then it is a fire retardant material. But if you use plywood, then that's not protection. No, plywood would help spread the fire because it is a flammable material, the plywood. Okay, and non-retardant plastic materials are also not passive fire protection. Okay, so passive fire protection is the selection of materials that have fire rating. Like for example, fire rated walls, fire rated floors, concrete floors, no, fire rated ceiling and roofs, hollow blocks walls, gypsum board, fiberglass cement board, hardiplex, no, and what else? Marble and so on, stone, finish, concrete. Of course, fire and smoke control doors, fire and smoke stopping seals, fire-rated protective coatings, fire and smoke dampers, fire-rated glass, fire-rated landing doors, fire-rated ducting. All of these materials in a building that are fire-rated are considered passive fire. Okay, so let me just show you schematically. So here is a building. So if you select this wall to be of concrete, then that means it will increase the firefighting capacity of your building. Okay, let's have a short break again, ladies and gentlemen. Pasensya na kayo. I just came from a visit in Valenzuela this afternoon, and there was heavy traffic when I came back, so a little tired. Few moments. are back. We are back. Let me see who are in the chat back again. And okay. Okay, from Yuri Taraki, Binzar Logistic Hub in King Abdullah Economic City. Oh, so that's in Saudi Arabia, Yuri, no? That's good. So I repeat, it's Binsar Logistic Hub in King Abdullah Economic City. Okay. Mark Ramsey, hi sir. Are all commercial kitchen restaurants requires fire suppression? Yes, they should be provided. Otherwise, you run the risk of having a fire that could not be controlled. Yuri Taraki, we have also oxy reduction system used in our high bay areas, almost 50 meters high, fully automation warehouse. So, okay. So you're saying that you have oxygen reduction at the upper portion. That means you reduce the oxygen in order for you to try to put out the fire. Yeah. Okay. So, but the oxygen that you remove is in the upper elevation, and maybe the rooms are not. You don't have many people there, no. But of course, the people will have to run and get out. No? Okay. So that's good. It is also a means of okay, and then Yuri Taraki, 2 weeks ago, our Novec 1230 KIDE was activated by false alarm. 2-cylinder was empty for only 10 minutes. We replaced with new tanks. We found out that false alarm was caused by dust due to sunstorm. Oh, so meaning to say you had a sunstorm there and the dust came in and it was detected by your detectors. It was assuming that it was a smoke, no, or a fire or a smoke, and then it actuated your Novec. So there's something. If it is an air-conditioned room, how come the dust came in? Anyway, so I'm just curious, no, Yuri, no. So you're saying you found out that the false alarm was caused by dust due to a sandstorm. So okay, I guess your rooms could be air conditioned and dust should not just be able to come inside it, no, so that it will affect the unless you know. So Yuri Taraki, what is the standard cut off pressure of pumps? Uh, the cut off pressure of pumps depends on the design, no, because for tall buildings it depends on the calculated hydraulic pressure. Okay, so it depends, no. So you have to do the designer has to do the calculation, hydraulic calculation, to determine what would be the operating pressure. Okay, because in the hydraulic calculation you have to design your system, your fire pump pressure, as well as the capacity in GPM or gallons per minute, with the farthest sprinkler in mind. So say for example, if you have a 50-story building, say just an example, 50-story building, and you will have the fire pumps there on the, let's say, on the basement, or on the basement. So the farthest sprinkler on the top, on the 50th floor, will be analyzed going down to where the fire pump is located. Whatever will be the computed pressure because of the high elevation of the building, then that will be the needed setting point of the cut-in pressure, no, and of course the cut-off. No? So as you remember, the jockey pump runs every now and then to maintain that pressure, so that on the last sprinkler at the topmost floor, it will have at least a minimum of the specified pressure of the NFPA, which is 7 psi. Okay, you imagine 50 stories and the farthest on the floor, the top floor, then whatever is the distance of that with respect to where the fire pump is located on the basement or on the ground floor. Okay, that farthest sprinkler should have at least 7 psi minimum pressure. That is the design. Then of course after that you will be able to, the designer will specify the pressure, the rated pressure of the fire pump. Okay, so of course during commissioning you have to set now the pressure, not really just simply to create the 7 psi. Usually you select a pressure and a GPM higher than the computed, than the design pressure and design GPM. Okay, so I cannot answer exactly what would be the recommended. It will depend on the calculated or design pressure. Okay, what's the next question? We have only oxy reduction 50 meters. That's finished 2 weeks ago. Then Ureteraki standard cut. Okay, answered that already. Harold Corpus, hi sir, thank you for this webinar. Yeah, welcome. So let's continue to finish this. So my suggested materials are these ones, no? For a passive fire protection, although this is the area or the field of the architect as well as the contractor and the owner, is to use reinforced concrete, of course, and concrete hollow blocks for walls. Then you can also use gypsum boards or perlite panels. So these are fire retardant materials. Fiber cement board, which is hard-deflex. Then of course granite for finishing, for finish. Marble panels, yes. Ceramic tiles, yes. These are fire retardant. Red bricks also. Adobe blocks. Thick glass panels. And then asbestos cement panels. So these are materials that do not burn. Okay. How about those that get burned? Here they are. So I do not recommend plywood panels, plyboard panels, particle board panels, lawanit, no good. Tin metal sheets, no good. Plastic sheets, panels, no good. Carton and similar, even cork materials. So all of this, no, of course, curtains and some other materials are also, unless you cover them with chemicals that would prevent fire. No? There is this chemical, but of course you'll never know when the chemical is lost. Okay, because the chemicals are colorless. So I don't know. Okay, so those are the passive fire protection with respect to the material. Now we go to the active fire. Active fire, like I said, sprinklers, fire pumps, jockey pumps, fire hose cabinet, Siamese twins, and so on and so forth. All of these materials, even the fire water tank, no, and so on and so forth. But what is the basic requirements of the fire code today, Philippine Fire Code? My interpretation is that if a building is used as a hotel, a motel, a dormitory, a hospital, then automatically you have to provide sprinkler system. Automatically. Even if it is less than 15 meters, in the old fire code, it mentions 15 meters and above, that's the time you provide sprinkler system. In the new fire code, in the 9514 fire code, even if it is less than 15 meters, even if it is 1 story, 2 story, 3 story, 4 story, as long as it is used for hotel, motel, dormitory, and hospital, meaning to say guests are sleeping in the house or in the hotel, then you have to provide a sprinkler. Okay? Otherwise, if it doesn't, of course, there is another requirement. If flammable materials are stored in that building, even if it is 1 story, 2 story, 3 story, less than 15 meters, if there is flammable materials stored, then you must provide sprinkler, automatic sprinkler system. Okay? Otherwise, then it's possible not to use sprinkler system. Okay? So we have two systems in water protection or fire suppression using water. You have the wet system and the dry system. You say wet system when there is a water inside the pipes with the jockey pump running every now and then to maintain the pressure. While dry system is there is no water inside the pipe, so water will only come in when a fire pump will run, okay, will operate. So like a dry standpipe, the dry standpipe of building, there is no water there. While the wet standpipe has a water already ready to come out and sprinklered to the fire. So here we have three types when it comes to the arrangement. On the left is the simplest, the three type, and then of course the loop type here, and then here the grid type. You will take note that the three type, when you maintain, let's say, the main horizontal or vertical, the entire system will be shut down. So you have to provide, when you do that, you have to provide fire watch in all locations, in every floor, when you touch this. But if you have a loop type, then you can isolate the one that needs to be maintained, and then still the others would have an operating fire protection or sprinkler system. And of course, at the right is the grid type. So you have so many alternatives when it comes to maintaining any portion of the system. Here is an elevation drawing of an active fire protection with sprinklers. Water is coming from the public main line and comes in here and goes to the different sprinklers, like this one, this one, and this one, and this one, and also here also, and here, and you have here a bulb. Okay. Now we have this kind of pumps. Horizontal split case. This is the most popular. Then here is a vertical inline pump. So the footprint is so small. You have here the intake and the discharge. Okay. So very small in space, while this one has a big base. Then here is the turbine, vertical turbine pump for submersible pump. So that means if you have a underground tank, you should use this vertical turbine pump to make sure that no cavitation will happen. Okay. And here is the graphs for the pump motor characteristics. And here you have a question: is fire pump normally FM approved? And you are listed. Not anymore. It is no longer required in the fire code to have a fire pump that is FM approved or ULFM approved. No longer. In the old fire code, yes. But today, in the 2008 fire code, no need. As long as you have a capacity of fire pump that can deliver the required pressure and volume or flow to the FDAS sprinkler as calculated in the design. Okay, so here is just a schematic showing a complete sprinkler system. Here are the jockey pumps, jockey pump, fire pump here, number 2, fire water tanks, test valves, then sprinklers, and so on here. Here is you have fire department connection here, and then you have fire hose cabinets added here. Here are pictures of fire department connection. You have this one, and this one, or you have the Siamese twins. But here you will notice there are two pairs of Siamese twin. Usually one pair of Siamese twin, you have one riser pipe. Okay, one pipe of riser. So with this. But here, you will have two riser pipes. Okay. Fire hose cabinet, usually about up to 50 meters to 100, 50 feet to 100 feet in length. And here are the types of sprinklers: conventional, upright, pendant, and so on and so forth. The operating pressure is 7 psi here, and minimum operating temperature is 57 degrees. Other types of sprinklers would have a higher temperature rating depending on the application. And here is just illustration. You can have also an elevated water tank that can supply fire water to your last sprinkler. Here, take note that in the drawing there is no fire pump. It's just only the pressure of the tank that supplies the pressure of minimum of 7 psi and the last or the farthest sprinkler. Okay. And here is another schematic showing there is no jockey pump. Here you have here the fire water tank, and there is only one pump here. Usually you have a fire pump and a jockey pump. Like I said, the jockey pump is the one that maintains pressure in the entire building. But in this illustration, there is no jockey pump. The pressure on the last sprinkler is provided by this elevated tank. This one. Not a very big tank. It's just enough to maintain a pressure on this last sprinkler. Okay. So, is this acceptable? Yes. Because it maintains the pressure in here. What is the advantage of this? Well, there is no jockey pump that is every now and then running, consuming electricity. Why is the jockey pump running all the time? Yes, to maintain the pressure. And why does it need to continuously run? Of course, sometimes there would be leak in the piping, especially in the check valve of the pumps. There would be loss in pressure because of the leak in the gate valves and in the check valves. Okay. Sorry. Then the fire sprinkler system requirements. Again, as long as the fire pump has enough capacity, then no need for that. ULFM requirements, because usually the ULFM required pumps are higher by almost 50% higher. That means 150% higher. Here is just the table of the fire pumps. You will notice the GPM capacity here and the corresponding intake pipe and discharge pipe. Okay, so the first column is GPM, the second column is the volume flow in liters per minute. Okay, there are several types of application for the sprinkler system. You have the light hazard, and all of these are there. Educational, schools, hospitals, institutional, libraries, museum, and so on and so forth, including residential, hotel, dormitories, offices, and malls, commercial. So that's under light hazard. The next is ordinary hazard. But take note, in the ordinary hazards, there are several items that usually are in our present buildings, like in malls. In malls, we have parking. This one, parking. And we have bakeries there, no? Sometimes you also have laundries. Okay? And they have plenty of restaurants. So therefore, uh, in in the first type, which is the light hazard type, like light hazard for commercial or malls, if you have a parking, that would upgrade it therefore to ordinary hazard type. Okay, then here is the ordinary hazard group 2, because the first one is ordinary hazard group 1. This one ordinary hazard group 2, and then extra hazard group 1, mostly industrial, and the extra hazard group 2 there, also industrial. Sorry. Okay, so here the difference between the light hazard in the number of sprinklers that a certain size of pipe can supply. So example is, for a 2-inch pipe, up to 10 sprinklers. For a 3-inch pipe, up to 60 sprinklers. Okay, so take note, 2-inch, 10 sprinklers, and then 3-inch, 60. And the next slide, you will notice ordinary hazard. The 2-inch is 10 sprinklers, and now the 3-inch is 40. Initially, it is 60 sprinklers, but in the ordinary hazard, then it has reduced the allowable number of sprinklers. Okay? Extra hazard, much more lower, because in the 3-inch is only 27 sprinklers, and in the 2-inch is only 8 sprinklers, and so on. Okay? So that's how it is. And let me go back again to the chapter. Okay, let me see. What is the standard cutoff pressure? Harold, and then Mark Ramsey. Hi sir, are asbestos still safe to use for passive FirePro? Yes. The only problem with asbestos is that in the manufacturing areas, according to the asbestos fibers can cause lung cancer. Remember, the asbestos fiber, the fibers of the asbestos material is cancerous. So that's the problem. So, but if they have a means of preventing it from, flying and so that these workers in those areas, manufacturing areas, the fibers will not be, inhaled. Then of course, it has no relation with firefighting equipment. Like I said, the asbestos is only bad when the fibers are smelled or taken inside the lungs, and then it is cancerous. Okay. So here is a ground floor. As you would see, the sprinklers here, there, and there, and also here. So you will take note that in this large area there are how many sprinklers? 1, 2, 3, and 4, 5, 6, 7, and 8, 9, 10, 11, and 12. Of course, there is one here, 13, 14, 15, and there also 16. This is elevator. Okay. And at the stairwell, there is one there. Beautiful. Then second floor, there are more sprinklers here, and you will notice a typical floor layout from the 3rd to the 16th floor. 3rd to the 16th floor. So it looks like it is a studio unit where you have a bed area, bedroom, and a toilet and a kitchen here. Okay. And last floor, 17th floor. So it looks like it is a multi-purpose floor, no, or building floor. Okay, let me go back again to the chat. No more, no added question. Okay, please ask your questions so we can answer them. Not feeling well. Okay, so here we have we have here the sample details: fire hose cabinet, Siamese twin, test flow control valve here, then cistern tank, support detail, and so on and so forth. So just copy paste this in your design drawing. Okay, so that's it. I'm not so feeling well. Let me answer your questions. Can you ask your questions now so we can answer them? Big point of interest is in fire, of course, the smoke detection, and of course the toxic gas detection here. Oh, let's go back to the here. This is the area that is critical. There. Okay. Questions, gentlemen? Anyway, so let's greet again those who are in our chat group. John Docos, London Sisters. What's the name again of London Sisters? Because I know this is not you. You're just using the account of your daughter, I think. Charles August Doke. Yeah. JCG. What is this? Lino Hernandez. Ten Apolinario. Richard Rehidor. Richard, were you able to get that project which you were asking how much is the design fee? Marlon Pascual. Ed B. Is Ed B. Ed Briseño? Of course, again, Richard. Mike Ramsey. Yuri Taraki. Mike Ramsey, Yuri Taraki. And then Harold Corpus. Okay, so any more questions? Like I said, I'd like to emphasize this gas detection, toxic gas detection, which is not yet present. That's why I really like to advocate for this. That the IRR, the National Building, the Bureau of Fire, as well as the Office of the Building Official, and the DPWH, Office of the Building Official, and the National Building Code Committee should include this in the fire code, IRR of the fire code, as well as in the IRR of the National Building Code, so that we'll be able to protect lives in this kind of buildings and closed buildings. Okay. Is there any more questions, gentlemen and ladies? Anyway, so there are no more questions in the chat box. If you don't have any more questions, let us now proceed to the closing prayers. Again, first we thank you all for joining us in this webinar. In the name of the Father, Son, Holy Spirit, Amen. Thank you, Lord, for this opportunity again to discuss these very critical items, especially on carbon monoxide detection, toxic gas detection and extraction. And thank you, Lord, for keeping us away from the sickness, or keeping away the sickness from us, Thank you, Lord, for keeping us away from accidents also. And thank you, Lord, for always guiding our work. I mean, us in our work, in our means of livelihood, in our, if you have businesses, for guiding us, for blessing us, and also our family, Lord God, our loved ones. We thank you for keeping them away from or protecting them, Lord God. All of this we ask in the mighty name of your Son, Jesus Christ, who lives and reigns with you forever and ever. Amen. Again, thank you very much. Keep safe, stay fit, and God bless us all. Good evening.